All right, so when you think about oil production, you probably picture one of those old pump jacks just kind of bobbing up and down in a field somewhere. Well, you're going to want to throw that image out the window. That picture is being completely redrawn by some of the most insane engineering happening on the planet right now. We are talking about a totally new age of energy being pulled from the world's most extreme environments.
So let's just reset our expectations right from the start with a simple question. What even is an oil rig today? The answer, you'll see, is pretty wild. Because it's not just one thing anymore. It's a combination of absolutely incredible technologies. For starters, it's a floating factory. I mean, a massive, city-sized vessel just parked out in the middle of the deep ocean. And get this, it's capable of going from a brand new discovery to full-scale production in less time than it takes most cities to build a new bridge. At the same time, on land, it's this incredibly advanced automated drilling machine. It's literally pushing technology to its absolute breaking point to punch holes deeper into the Earth's crust than we ever thought was possible. And then back up on the surface, it's a whole fleet of smart, self-driving electric trucks just quietly and efficiently hauling material around 24/7. They're completely changing the game when it comes to the logistics and the environmental footprint of these huge mining operations.
So here's the bottom line. The era of easy oil, well, it's pretty much over. To keep up with demand, the industry is pushing into frontiers that honestly sound like something out of science fiction. In this explainer, we're going to explore three of these new frontiers: the deep ocean, the deep earth, and what I'm calling the smart surface. Okay, our first stop is going to take us hundreds of miles offshore into the ultra-deep waters off the coast of Guyana. Believe it or not, this place has become the global blueprint for how you develop gigantic offshore oil fields at, and I mean this, breathtaking speed. Now, the thing that should make your jaw drop on this slide is that timeline. Under 5 years, from the day of discovery to the first barrel of oil. In this kind of deep water environment, that's just unheard of. So what's the secret? It's this thing called a floating production, storage, and offloading vessel, or FPSO for short. You can basically think of it as a plug-and-play oil facility. By using standardized modular designs like SBM Offshore's fast-forward hulls, companies can slash engineering time and get these massive projects up and running faster than ever before. And make no mistake, this is not a one-off experiment. Just look at the scale of this operation in just one chunk of ocean, the Stabroek Block. By 2025, a whole fleet of these giants was already out there working. The Liza Destiny, the Liza Unity, the Prosperity, and the absolutely enormous One Guyana. This is industrialization on a scale that's hard to even comprehend, and it's all happening out in the middle of the ocean. And the amount of oil these things can produce is just staggering. A single big FPSO like the One Guyana can process 250,000 barrels of oil every single day. But these aren't just giant funnels. They're super sophisticated processing plants that are also equipped to re-inject huge volumes of natural gas and water back down into the reservoir. That's a critical step to keep the pressure up and squeeze out every last drop of oil from these deep water fields. Okay, let's head to our next frontier. We're moving from the deep ocean to the deep earth. We're going way inland to the super remote Tarim Basin in western China. Here, engineers are facing a totally different but just as massive challenge, drilling to depths that are almost unbelievable. I want you to meet the Shen de Taiwan. Now, this well isn't some kind of publicity stunt. It's a strategic necessity. You see, in this specific basin, the huge majority of the oil, we're talking over 80% of it, is trapped in reservoirs more than 6,000 meters down. So to get to it, they have no choice but to go deeper than almost anyone has ever gone before. And in early 2025, they hit a mind-bending depth of 10,910 meters. To try and put that into perspective for you, that's like taking Mount Everest, flipping it upside down, and then continuing to drill past its peak for another 2 full kilometers. Just an incredible feat of engineering. And the conditions down there are just as extreme as the depth. The pressure at the bottom of that hole is over 145 megapascals. That is more crushing force than you would find at the very bottom of the Mariana Trench, the deepest point of any ocean on Earth. The temperatures are so high they can literally melt standard electronics. The engineers who worked on it, they described the project as facing world-class difficulties. So how on earth did they solve it? Well, they built a brand new tool for the job, the world's very first 12,000-meter automated drilling rig. It's a machine designed from the ground up to operate under these absolutely punishing conditions. All right, for our third and final frontier, we're going to come all the way back up to the surface because the revolution isn't just about going deeper or farther out to sea. There's another one happening in how we handle really complex resources on land, from the oil sands in Canada to these enormous open pit mines. So let's take a look at the Canadian oil sands. For a long time, the main method, called SAGD, was basically a brute force attack. You inject tons and tons of high-pressure steam deep into the ground to melt the super heavy oil, called bitumen, so you can pump it out. It worked, but it used a crazy amount of energy and water. The new method, SAGD, is way smarter. Instead of all that steam, it uses a light solvent. And the results? They're dramatic. A 60% drop in greenhouse gas emissions and a 30% boost in how much oil they can recover. It is a total game changer for the industry. But wait, there's another huge benefit that comes with this. The oil that comes out using this new solvent tech is way less thick. It flows much more easily. This means it's pretty much pipeline ready. It could completely eliminate the need to blend the bitumen with expensive diluents just to ship it. And that, in turn, could free up a ton of capacity in the pipelines we already have. Now let's switch gears and talk about the actual vehicles that move all this earth around. We are right at a tipping point for the electrification and automation of heavy industry. In both Canada and in China's huge open pit mines, we're seeing autonomous battery electric haul trucks being deployed at a really serious scale now. And really, this chart says it all. A regular diesel engine in a haul truck is, on a good day, maybe 30% efficient at turning fuel into actual movement. The rest of that energy, just wasted as heat and noise. A battery electric vehicle, 90% efficient. That's a threefold improvement. And on top of that, they need about 40% less maintenance. When you combine that with AI that's optimizing their routes, they can operate with a level of efficiency that's just flat out impossible for a human-driven fleet. So we've seen how all this incredible technology is unlocking these extreme resources, but that kind of begs a bigger question: why? Why go to all this incredible trouble? And the answer is pretty simple. Not all oil is created equal. The quality of the crude oil is what determines its value, and the really good stuff, well, it's getting a lot harder to find. Okay, the first key thing you need to know about is its density, and we measure that on something called the API gravity scale. It's actually pretty simple. Lighter oil is better. It's less dense, it flows easier, and most importantly, when you refine it, you get a higher percentage of the really valuable products, like gasoline and jet fuel. The second critical factor is how much sulfur is in it. This gives us the whole sweet versus sour classification. Sweet crude has very little sulfur, which is great because it means it's less corrosive and cheaper for refineries to process. Sour crude has a lot of sulfur, which has to be removed, and that adds cost. So, naturally, sweet crudes always sell for a premium. So let's see how this all comes together in the real world. This table lays it out pretty clearly. At one end of the spectrum, you've got your benchmarks like WTI and Brent. See how they have high API gravities and really low sulfur? That makes them top-tier light sweet crudes. Then you go all the way to the other end, and you have something like Western Canadian Select, or WCS. It has a low API, meaning it's super heavy, and a high sulfur content, making it heavy sour crude. That huge difference in quality has a direct impact on the price each barrel gets on the global market. So, from floating factories in the deep ocean, to automated drillers miles underground, to intelligent electric fleets roaming the surface, the global race for energy is clearly pushing human ingenuity to its absolute limits. These incredible feats of engineering are making what was once impossible possible. And that really leaves us with the ultimate question. As we unlock these vast, new, and extreme resources, what are we as a global society going to choose to do with all this power?